Hi folks, welcome to day 19. Today's going to be your review day. This might be a little bit of a longer video, but I will go through an example of each type of problem that you're going to have on your quiz tomorrow. Alright, so your quiz tomorrow is going to have 24 questions. Now those first three, it might not exactly be the first three because they're not necessarily in this order, but three of them are going to be nth root problems. That means three of them you're going to be told, okay, hey, given n is 4 and a is 81, find the nth root of a. And remember, all we have to do to do that is plug it into our nth root of a formula. So we have the fourth root of 81. And since this is an even root, I know that I'm going to have a plus and a minus answer. And the fourth root of 81, I have to ask myself, what to the fourth power is 81? I know 3 to the fourth power is 81, or 3 times 3 times 3 times 3 is 81. Remember, you're welcome to plug that into a calculator to check your answer. In an ideal world, we wouldn't be using calculators because we'd be in the classroom, but truth be told, you can use a calculator throughout your life anyway, so that's not going to affect you too much, all right? But again, yeah, you can use a calculator to check your answer if you need to. Feel free. But you're going to have three of them that are like that. Keep in mind that if n is an even number and a is less than 0, right? If this was like a negative 81 and it's a fourth root, that doesn't exist. There's no real solutions. Right? An even root, an even n would be like 2, right? If n is 2... and a is like negative 49. The square root of negative 49 doesn't exist. It's an imaginary number, right? It's 7i. That doesn't exist. It's not a real number, so you can't find the root of it. There's no real solution, and we're not going to worry about i's and stuff in our quiz. It will be a multiple choice quiz, though, so hopefully that'll help you out. Keep in mind, though, it's a multiple choice quiz that's going to have to ask you, if this was your problem for your first problem, it'll ask you, what are the nth roots of a when n is 4 and a is 81? And you're going to have to click the box that has 3 and click the box that has negative 3. There's probably also going to be some random box that has, some random solution that's not the answer. And then something that's no solutions. All right? So you're going to have to click both of the boxes if you have a plus and a minus. So if n is even and a is less than 0, there's no real solution. If n is even and a equals 0, then the solution is 0. If n is even and a is bigger than 0, then you have that plus and minus. If n is odd and a is less than 0, it just means that you have a negative solution. So if we had the third root of negative 8, that's negative 2. Because negative 2 times negative 2 times negative 2 equals negative 8. All right? If n is odd and a equals 0, again, the solution is 0. And if n is odd and a is bigger than 0, then it's just one positive answer. So again, n is even, a is less than 0, no real solutions. N is even, a equals 0, 0 is the solution. N is even, a is bigger than 0, you'll have two solutions, one positive, one negative of the same number. If n is odd and a is less than 0, your answer will be negative. If n is odd and a equals 0, your answer is 0. And if n is odd and a is bigger than 0, your answer is positive. So again, 3 questions on nth roots. We're also going to have 6 questions that are on evaluate. It'll say something like, evaluate the following. So evaluate 2 to the negative 3. Well, we're going to have to use our properties of exponents and radicals in order to solve these problems. So when we're evaluating, the difference between evaluating and simplifying is that evaluating equals a number. Simplifying equals an expression. All right? So here we have 2 to the negative 3. If I look back at my notes for the properties of exponents, I know that there's something special about negative exponents. A negative exponent brings the entire term that it's attached to into the denominator. All right, so that means that 2 being raised to the negative third power is the same thing as 1 over 2 to the positive 3 power. From there, we can go ahead and simplify. 2 cubed is just 8. So we're left with 1 over 8. That's just a number, so that's our evaluation piece. But you might also have things that look like 49 to the negative 3 halves. Right? Those are the ones that are like super scary because they're so different. But keep in mind, you can always take something like this and rewrite it. So anytime that we have a negative exponent, we can always take it and put it into the denominator. If we have a fraction exponent, right, a rational exponent, we can always rewrite that as a root. And remember, the denominator is in the dirt with the roots, so it goes on the outside. And the exponent, right, the numerator, this piece here, that is our power, so that goes on the outside. All right, so I have 1 over the square root of 49 cubed. And the reason why I put the cubed on the outside is because I know the square root of 49 is a nice number, right? It's plus and minus 7. So it's a lot easier to do 7 cubed than it is to do 49 cubed and then square root it. All right, so 7 cubed gets us 343, so I have 1 over 343. And technically, since it's a square root, I will have a plus and a minus here. And so technically, I'll have a plus and a minus there. On your test, I don't think you're going to have one like that, though, or on your quiz, I should say. But that's how you'd walk through that one. All right? So keep in mind, you can always rewrite your rational exponents as roots if it makes more sense. All right? So evaluating is always going to be equaling to a number at the end. So you can see here we had a number, down here we had a number. All right, so evaluate means you're going to end up with a number at the end. There's 6 of those problems. Then there's 9 simplifying problems, and that's like the bulk of your test are these simplifying problems. And simplifying means you're going to end up with something that's probably not super pretty at the end, but it's going to be okay. So, for example, you might have something like 8 squared to the 1/4. We're going to have to try and simplify this. All right? Part of how we're going to simplify this is we're going to use our properties of exponents and our properties of radicals. I strongly recommend going back through and writing down all of those properties if you haven't already. It's going to be extremely helpful for your quiz tomorrow. So for our exponent here, I know with my properties of exponents, when I have an exponent on the outside of a parentheses, I can bring it on the inside and then multiply exponents. So I'm going to go ahead and do that for this problem. So I have 8 squared to the 1/4, which is the same thing as 8 to the 2 times 1/4. 2 times 1/4 is the same thing as 2/4, right? Because our numerators multiply across and our denominators multiply across. And 2 is the same thing as 2 over 1. But 2 over 4 is the same thing as 1/2. Now, depending on what it gives you, like since this is a multiple choice test, you might have something that looks like 8 to the 1/2 as a solution. but you might have it in terms of a radical. In a radical form, remember, we're going to take this denominator. It's in the dirt with the roots. So our root is going to be a square root, and it's going to be the square root of 8 to the 1 power. Since it asks us to simplify, there is one other thing we could do, and we could split this square root of 8 into a square root of 4 times 2. Using our properties of radicals, we could then split this up into the square root of 4 times the square root of 2. And the reason why we want to do that is because the square root of 4 is 2, so then we're left with 2 times the square root of 2. So again, depending on how your solutions offer it, your solution might be 8 to the 1/2, or it might be 2 to the square root of 2, or 2 times the square root of 2. It's just really important that you're keeping in mind that exponents are the exact same thing as radicals, so they can, they're interchangeable, all right? Let's try a couple more like that, though. So you might have something like 6 to the 3/4 over 6. We're going to use our properties of exponents in order to simplify this. So when we have 6 to the 3/4 divided by 6, that division of 6 technically has a 1th power to it. All right? Anything, like every number and every variable, they always have an exponent. If their exponent isn't there, right, like we had just a division of 6, if the exponent isn't there, the exponent is 1. All right, so that was something you learned way back in algebra, and probably also in like pre-algebra in middle school, but I wanted to make sure I emphasized it again when we're going through and reviewing. The reason why that's really important is because this is what makes it so that way we can actually simplify this problem. So when you have divisions, when you have the division of two numbers with exponents, as long as the bases are the same, you can go ahead and just subtract the exponents. So the base is 6, and my exponents are 3/4 and 1. So you take the top exponent and subtract the bottom exponent. 3/4 minus 1 is the same thing as 3/4 minus 4/4, since 4 divided by 4 is 1. All right, and then 3/4 minus 4/4 is negative 1/4. Or, since we want everything to be positive exponents when we can, 1 over 6 to the 1/4. And keep in mind, if you can't do this 3/4 minus 1 equaling to negative 1/4, if you can't do that in your head, that's okay. If you can't subtract fractions well because fractions are difficult, that's okay. Use a calculator. I'm totally fine with that. All right. All right. Let's work with a little bit more of a challenging exponent problem. This will be the last exponent problem I do, and then I'll do a couple radical simplification problems. All right. We have 7 to the negative 2/3 times 7 to the 7/3, and all of that is being raised to the negative 5th power. You're going to have one that looks really, really similar to this on your test tomorrow, and that's why I wanted to go through one like this. So just like with the problem we just did, we have bases that are the same, right? And that's why we're able to simplify our last problem. We can do that exact same concept, except for when you have bases that are the same and they're being multiplied, then their exponents add. And I'll let you know, typically speaking, when you have parentheses, you're going to want to try and simplify anything inside of the parentheses before you move to the outside. All right, so we're going to go ahead and simplify. We're going to say, okay, since these are being multiplied, then all I have to do is add my exponents, so that I'm still going to have a base of 7, but then I'm going to have negative 2/3 plus 7/3. And that's still being raised to that negative 5th power. Negative 2/3 plus 7/3 is the same thing as negative 2 plus 7 divided by 3. Negative 2 plus 7 is just positive 5. So we're left with 5/3 as our exponent. So again, all I did from step 1 to step 2 was I used my, I think it's called power of a product. So I went ahead and was able to simplify because we have multiplication going on with the same base. And when you have multiplication of the same base, your exponents add. Here, really similar, we had division of the same base, so our exponents subtracted. All right? Then what we went ahead and did was added together our two exponents, so negative 2/3 and then positive 7/3, and we got 5/3 as our new exponent. So we had 7 raised to the 5/3 power. Then we're going to go ahead and we're going to have to distribute in that negative 5. When we do that, our exponents multiply. All right, and that's that power of a power. So the second rule we learned, second property we learned. And this is easiest to do by multiplying your fractions. So we have still our base of 7. Our numerators, we have 5 times negative 5. So we get negative 25 as our numerator. And for our denominators, we have 3 times 1. So our denominator is 3. Final step, this is a negative exponent. We want everything written as positive exponents, so we go ahead, move that into the denominator as 1 over 7 to the 25/3. And this is what makes this a simplification problem instead of an evaluation problem. I'm not going to try and figure out what this gross number would be. That's going to be it's likely a gross number, and it's not going to be beneficial to split it up, so we don't. All right? All right, so we saw a little bit of radical simplification over here when we had to take our square root of 8 and break it up into the square root of 4 times 2, and then break that up into the square root of 4 times the square root of 2, and then we simplified the square root of 4 to be 2 times the square root of 2. You're going to have to do something similar on your test tomorrow. I recommend trying to simplify something like the square root of 3 and see if you can break that down. Or maybe let's go ahead and try out the 4th root of 32. So to split up the 4th root of 32, what you're going to try and do is you're going to try and find 4th roots inside of that 32. All right, so perfect 4th roots. So my first perfect 4th root, meaning my simplest number raised to the 4th power, would be 1 to the 4th power, which is just 1. 2 to the 4th power is 16. And I know that 16 is related to 32 because 16 times 2 equals 32. So that's going to be helpful for us when we're trying to split up this 4th root. So instead, I'm going to split this 32 into 16 times 2. What we can then do is split this into 2 4th roots. So I'd have the 4th root of 16 times the 4th root of 2. Now, the 4th root of 2 doesn't break down anymore, but the 4th root of 16 is 2 because 2 to the 4th is 16. So our 4th root of 32, we can actually break into 2 times the 4th root of 2. All right, so you will have a problem similar to that on your test tomorrow. You're also going to have a problem similar to this. So if we have like the square root of 7 times the square root of 28. Square root of 7 is not a pretty number. Square root of 28 is not a pretty number. But what we can do is we can break up that 28 into some useful things. So we're going to leave the square root of 7 over there. But I know if I think of my factors of 28, I have 1 in 28, right? I have 2 and 14. Some of you that are quicker at mental math are like, wow, that took her a while. You have 2 and 14. Then you have 4 and 7. Here's how you're going to pick which one works best. In our first option, we have 1 and 28. While 1 is a perfect root, 28, the square root of 1 is just 1, so that doesn't change the problem at all. All right, so we can automatically eliminate that one. That doesn't help. We could break the square root of 28 into the square root of 2 times the square root of 14, but neither of those are perfect square roots either. So why would we choose those? But down here we have the 4 and 7, so we can actually break this 28 into the square root. Instead of the square root of 28, we can break it into the square root of 4 times 7. And that's really useful because then we can break apart our 7, our square root of 4, and our 7. And we'll want to do that because the square root of 4 simplifies. The square root of 4 we know is just 2. But also, we now have the square root of 7 times the square root of 7. So just like we can take something and we can take like a square root and split it into its factors, we can also take factors and put it back into a square root. So what we can do here is instead of the square root of 7 times the square root of 7, we can actually have the square root of 7 times 7. And that's one of our properties of radicals that's super important. The reason why we want to have that is because 7 times 7 is 49, so the square root of 49 is 7. So then we actually end up getting a nice number. I did not know that we would get this nice of a number when I made this problem, but that's totally okay. It's all about the process. So we started off with something that looked like it couldn't simplify. We listed out our factors of all of them, tried to find perfect squares, and then when we found perfect squares, we went ahead and put them in. If this, instead of a square root, if this was like a cubed root, you'd be looking for perfect cubes in our factors. All right? All right. So keep in mind, just like when we went through and we can combine things with multiplication, we can also combine things with division too. So just keep that in mind when you're going through, because you are likely going to have a problem. Maybe it'll look something like the square root of 49 over the square root of 64, right? You can always go through and evaluate those individually, but you might also have something like, I don't know, maybe you'll have the square root of 900. Maybe you'd have like the square root of 900 over the square root of 100, which maybe that works out nicely, but it's actually a lot easier, rather than doing those two individually, it's a lot easier to do them under the same square root, because then you have 900 divided by 100, all your zeros just cancel, and you're just left with the square root of 9, which is 3. Well, plus and minus 3. But you can see this way of doing things is going to make your life a lot easier than trying to do them individually. Because these, when you try and simplify it first, then you can actually do things a lot more quickly, like in your head, than you would be able to when going through and trying them out. All right? All right, last but not least is this stuff that we've been working on this week. So I'm going to let you know right now, there's going to be no graphing. All right, I'm not going to require you to graph because it'd be really, really difficult to do online. But here's what you are going to have. You're going to be given a function, all right? So maybe we have something like negative 1/3 times the square root of x plus 2 minus 5. You're going to be given this function, or something like this function. It's not going to be this exact one. You are going to have to do the following. You're going to have to identify the domain. You're going to have to identify the range. You're going to have to identify if it has a stretch or a shrink. If it's reflected. And with that stretch or shrink, also what it's stretched or shrunk by. If it's reflected, it's horizontal shift, which just means how it's moving horizontally, and it's vertical shift, vertical shift, how it's moving up and down. All right. So I'm going to go ahead and start with the transformations because I think they're a little bit easier. If it has a negative sign, you know it has to be reflected. All right. So if there's a negative sign, it is guaranteed reflected. If it has a number out in front of the square root, it doesn't matter what that number is. If it has a number out in front, that's what it's stretched or shrunk by. All right. So if it was a stretch, it's going to be a number bigger than 1. If it's a shrink, it's going to be a number smaller than 1. So in our case, we have a number smaller than 1, so we'd say it's shrunk, and it's shrunk by 1/3, or by a factor of 1/3. All right. Similarly, if it was like a stretch, we'd say it's stretched by 3. All right. And again, on your test, you're going to have to select the box. Like maybe it's 3, 1/3, -1/3, and -3. Maybe those are your 4 options. I don't know. And you're trying to determine if it's stretched or shrunk. And maybe the question is something like, I'm actually going to look at the quiz real quick to show the exact verbiage. So maybe it'll say something like, which number is the vertical stretch, right? Or the vertical shrink. It'll ask you a question like that, and it'll specify either stretch or shrink depending on what one it is. But if it asks you, what number is the vertical shrink, or what number represents the vertical shrink, that's talking about this shrink portion that we were talking about, right? So if it asks you what number represents the vertical shrink, you are looking at just this number. You don't care about the negative sign because the negative has to deal with whether or not it's reflected. You only care about the A. You don't care about what's before the A. You don't care about what's after the A. You only care about the A. So since our A is 1/3, our answer would be 1/3. All right? When it asks about the horizontal shift, remember the horizontal is what's inside. And keep in mind, if this is a +2, right? Remember, it's normally x minus h, so if that's a +2, it's being moved to the left 2, or -2. All right? If it was a -2, it's being moved to the right 2. All right? So if it asks for the horizontal shift, you're looking for the number that's inside the square root. The vertical shift is this number outside the square root. So again, when it asks you to identify the number that is the vertical shift, it's just saying, hey, which one of those numbers is moving it up and down? So in this case, it'd be -5. All right. Now the last piece is the domain and the range, which we talked a bit about. But again, remember that domain, you're going to take what's inside your parentheses. I'm going to do a different color. You're going to take what's inside your parentheses set, or your square root for your domain. You take what's inside the parentheses. All right, so in our case, x plus 2 is inside the parentheses. All right, and you have to set that greater than or equal to 0. You set it greater than or equal to 0 because what's inside your square root has to be bigger than or equal to 0. You can't take the square root of a negative number. So we're going to go ahead and subtract 2. So we get x is greater than or equal to -2 for our domain for this problem. Your range, so remember, if it's not reflected, there's no reflection, then your range is always y is greater than or equal to your k value. All right? If it is reflected, then its y is always less than or equal to your k value. So in our case, we have a reflection. So our range would be that y, since there's a reflection, y is less than or equal to our k value, and our k value is -5. So our range would be that y is less than or equal to -5, and our domain is that x is greater than or equal to -2. All right? I know that that was a long video, but I wanted to make sure that I went through all parts of the quiz for tomorrow to make sure that you had lots of support for that. So if you want to, again, this isn't optional, but if you want to, I did post a study guide for you or a practice test. Honestly, most of the problems are a lot more difficult than your problems on your test or for your quiz on Friday, but I still wanted to give you an opportunity to try them out. I also posted, or I will post, the solutions for that as well. All right, best of luck on your test tomorrow. Thanks again for watching.